During elimination reactions, atoms are removed from two adjacent carbons in an organic compound, resulting in the formation of a double or triple bond between the two carbons and an inorganic byproduct. This reaction is opposite to the addition reaction in that a saturated compound becomes unsaturated. We'll study three types of elimination reactions. To decide whether a reaction is an elimination reaction, you should look at how many reactant and product molecules you have. In elimination reactions, you should have one reactant and two product molecules. Also look for saturated reactants and unsaturated products. The first type of elimination reaction is the elimination of a hydrogen halide. The special name for this type of reaction is dehydrohalogenation. The halogen and hydrogen from an adjacent carbon are removed, forming a double bond between the two carbons and a hydrogen halide as a byproduct. During this reaction, haloalkanes form alkenes. Let's look at the example of 2-bromobutane. In this reaction, we see that two products are possible. To determine the major product, we follow Zaitsev's rule. This rule says that the carbon containing fewer hydrogens will rather donate its hydrogen. Therefore, the double bond will form towards the middle of the compound, leaving the terminal hydrogens intact. But2ene is the major product and but1ene is the minor product. A strong base such as NaOH or KOH in an ethanol solution is used to catalyze this reaction. It's important that no water be present in this reaction. If water was present, the reaction would rather exchange the halide for a hydroxyl group and form an alcohol. The second type of elimination reaction is the elimination of water from alcohol. This reaction is called dehydration. And the result is the formation of an alkene and water as a byproduct. If we look at the dehydration of butan-2-ol, the hydroxyl group and a hydrogen on an adjacent carbon are eliminated. We use Zaitsev's rule again to determine which hydrogen is removed. The major product will form the double bond towards the middle of the compound, leaving the terminal hydrogens intact. But2ene is the major product, but1ene is the minor product. The reaction conditions for this reaction is a strong acid catalyst, such as sulfuric acid, and heat. The third type of elimination reaction we will be looking at is called cracking. In this reaction, very long carbon chains are broken into shorter chains for use in the fuel industry. At every point where a chain cracks, a double bond will form on one side and a single bond on the other. There are two main types of cracking. Thermal cracking uses high temperatures and pressures, but can be costly due to the high energy usage. Catalytic cracking solves this problem by using low temperatures and pressures under the influence of a suitable catalyst. Let's look at the following example. In this example, a 20-carbon chain is cracked forming 4 ethene molecules, 2 propene molecules, and molecule Y. To determine what molecule Y must be, we must count the number of carbons and hydrogens in the reactant. We find that we have 20 carbons and 42 hydrogens. In the products, we have 14 carbons and 28 hydrogens. Compound Y must therefore contain 6 carbons and 14 hydrogens, making it hexane.